What you could do is, actually there's a factorial button on your calculator, but it's not really worth doing it that way because I can show you a shortcut. So for example, in 6a, 10 factorial means 10 times 9 times 8 times, and you keep on going until you get to 1. So really what this is saying is I have 10 times 9 times 8, and if I'm going to keep on going, instead of going, hey, keep on going from 8, I could call that 8 factorial. Right? Keep on going from 8 down to 1. And then down below what I notice is I have a 2 factorial, which is 2 times 1, times 8 factorial. And by looking ahead, what I noticed is that those things reduce. So I don't really have to worry about it. And then up above I now have 90, and down below I have 2, and so my answer is 45.
Wow.
So Nate picks 42 as a number for n. Let's say I'm looking at letter B. And since Nate picked 42 for the number, if I were writing the B thing with numbers in it, here's what I would see. I would see 42 factorial, which is 42 times 41 times 40, blah, 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 until I got to 1. Down below, I would have seen 43 factorial, which is 43 times 42 times 41 times 40, blah, 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 all the way down to 1. And what do you notice?
Just 1 over 1 factorial.
Close. What do you notice in the orange?
1 over 43.
1 over 43 is correct. In the orange. Or in other words, the orange is telling me that there's one number larger on the bottom and everything else would reduce out. So let me show you how that works with parentheses like you see it here. I'm now going to extrapolate this and show you what this means. N factorial is really saying n, which was the number 42 that Nate picked, times that number, take away 1, which would then be a 41, times the original number, 42, take away 2, times the original number, 42, take away 3. And it would keep on going until it got to 1. So every single time, if you look at the numbers that match, 42, 42 minus 1, 42 minus 2, 42 minus 3, so on and so forth. Down below, if I have my n plus 1, which is representing 43 now, to get to the next number, that would be an n, which is 42. And then I would have a 41, which is 42 minus 1. And then I would have an n minus 2. And I would keep on going all the way down to 1. Remember, the number n is 42. Plug them in for the n's and see what happens. That's the same kind of thing. The whole point of this, though, is to notice that everything reduces out, starting with the n's. And so all that's left is the thing on the bottom, which is the n plus 1. And on the top, when we're multiplying, the number that's left over is a 1. So the answer is 1 over n plus 1. Letter C. In letter C, I notice that I have an n minus 2. So that means I go n minus 2. And then if I want to go one less than n minus 2, it now becomes n minus 3, because that's 1 less than 2, right? Because I took away 1 more. And then n minus 4, and it keeps on going until I get to 1. Down below, I start with n minus 4, and if I take away another one, that would now be n minus 5, and it keeps on going until I get to 1. And if I look at the reductions, what I notice is the first place they start canceling off is n minus 4, and then everything after that. So my final answer is that I have 2 things extra on the top, or in other words, n minus 2 times n minus 3. You may leave it that way unless they tell you otherwise. If you were to FOIL that out, that's n squared minus 5n plus 6, if you prefer to write it as a polynomial instead of 2 binomials being multiplied. I don't really care which way you write it.
1 billion.
Sometimes you punch things in on your calculator and you see something like dim.
Wait.
2.
N plus 2 on the top. N.
-2?
No.
+3?
No. Yes.
Yeah.
Woo! Because it's 1 less than 2. You got to take 1 away.
Wow.
And you just keep on going.
Are you serious?
Like a heart attack.
That makes no sense.
Huh?
On the bottom, I have pick a number, you guys. Plug a number in. See how it works.
Oh, I get it.
Okay. +4. Then it's going to be n plus 3. Then n plus
2.
and then it just keeps on going till 1. Last off. You'll notice that the 2's cancel out and everything afterwards. Which means actually you have a denominator of n plus 4 times n plus 3.
1.
And all the cool kids in math are foiling that out and getting n squared plus 7n plus 12. Don't be a fool. Be
Cool.
cool. I love rhyme. It's because I'm a giant.
Jolly.
Catherine Dykert. What does this symbol right here mean? And look, here's how I knew I already told you. Maybe you might want to circle that, Catherine. Awesome. Sum. They use the word sigma.
Well, you crossed it.
I know.
And that is this symbol right here. It means add things up.
Oh, now I see. Sorority.
Okay. Color coded. Here we go. Shut up and listen.
Shut up and cry.
Oh, I see the pattern here.
Shh.
All the way to 4. Because there's a 4 on top of the summation.
Don't tell people, please. Let them figure this out.
Jeez. There's something else.
Thank you.
$34 is my answer. What I want you to do is figure out what's going on and write yourself a little note about when you see a symbol with a sigma, something down below the sigma, something up above the sigma, and something to the right of the sigma, what should you do? Write yourself a note.
But it keeps growing until you can put it on top.
In part B.
Oh, wow.
Oh, that's where you started.
So in part B, same thing, different problem. I just need to figure out what each of these different values are. So in the brown, I got a 1. In the orange, I got -2. In the blue, light color blue that is, I got 6. In the purple, I got -24. And in the pink, I got 120. I don't really like that I did plus minus here, so I'm just going to write down minus because that bugs me. Oops. Now that color though. And then if I put that all together, I get 101. So you give that a shot.
Don't waste.
Make sure you can get 101. Sums